In this video I'm going to be looking at the solution to question 4 of the June 2011 Edexcel D1 paper. The topic of the question is matchings. The question talks about figure 3, which shows possible allocations of 5 workers, Adam, Catherine, Harriet, Josh and Richard, to 5 tasks numbered 1 to 5. And then figure 4 shows an initial matching of those people to their tasks. It says there are 3 possible alternating paths that start at A, and one of them is given as from A to 3 to R to 4 to C to 5. And we're asked in part A to find 2 other alternating paths starting at A. In part B, the question, we're to use the alternating path that's given to find an improved matching, and then finally in part C, starting from that improved matching, use a maximum matching algorithm to obtain a complete matching. And again, we must list the alternating path used and our final matching. Well, in part A of the question then, we're looking for alternating paths starting and at A. So if we're starting at A, we need to end up either at 2 or 5 on the right hand side. So let's look at our diagram here. From A, you can see that we can we could go to 1, which is matched to H, and then from H get to 2. So one of the alternating paths is from A to 1 to H to 2. So let's write that one down. We can have A, which is not currently matched with 1, but 1 is matched with H, which could then go to 2. So there's one of the paths. Then looking again, starting at A, we could go from the first part from A to 1 to H, which is matched with 3. Oh, sorry, I beg your pardon. Which could be matched with 3, but 3 is currently done by R, but R could go to 4, which is then matched with C, and finally C links up with 5. In part B of the question, we're asked to look at the improved matching generated by A to 3 to R to 4 to C to 5. So let's change the state of that. A becomes matched to 3, R will become matched to 4, and C will become matched to 5. So that's A to 3, R to 4, and not that one there, and C is matched to 5, and not that one there. So in total we have a matching which says A is matched with 3, C is matched to 5, H is still matched to 1, J is unmatched, and R is matched to 4. The marking then for these 2 parts of the question, there's an M1 mark and then 2 A marks for getting the alternating paths, and then just a single B mark for stating the final matching, or this matching at this stage in part B. The question goes on to start with that yes, so to start with the matching that we got in part B, and then use the maximum matching algorithm again to see if we can find a complete matching. So you can see this time we've got to start at J and to finish at 2. So the alternating path from J, well, if you look at our diagram figure 3, you can see from J we must go to 4. But 4 is currently matched with R. R could then be matched with 3. But 3 is currently matched with A. The only alternative for A is to match it with 1. But 1 is matched with H. And then finally that gets us to our objective 2. So our alternating path is J to 4 to R to 3 to A to 1 to H to 2. Let me show you that on the diagram. Here we're going from J to 4, but that's currently matched with R. We can go from there to 3, which is currently matched with A. Go from A to 1, but 1 is currently matched with H. And then finally going to 2. So let's put that onto our final diagram. We go from J to 4, not R, to 3, not A, to 1, not C, and then finally to 2. So that we've changed the state of our diagram, or our alternating path, to be J is matched with 4, R is matched with 3, A is matched with 1, and H is matched with 2. So our final matching is A is matched with 1, C hasn't changed in this case, so C is still matched with 5, H with 2, J with 4, and R with 3. The marking this time, there were a method mark and an A mark for the alternating path and changing its state, and a final A mark for this final matching. So 3 marks there for that part of the question. Well, that's the end of the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.